In this section, we will discuss about testing of hypothesis. Testing of hypothesis is a method for statistical inference. That is, testing of hypothesis is a statistical test used to determine our hypothesis for sample data true for entire data. This type of testing or comparing the data or comparing the hypothesis is called the testing of hypothesis. Next we can learn about some terms related to testing of hypothesis. First is population. Population is the largest collection of data. Otherwise we can say the same type of entire data is called population. For example, number of newborn babies in India is a population. Number of females in India, that is a population. Number of males in India, that is a population. So these are the example of population. So population is a same type of entire data. Next term is a parameter. Parameter is an important term in statistical analysis. It is any numerical quantity that characterizes a given population. Such type of numerical quantity is called a parameter. We can characterize that numerical quantity characterize a given population. Such numerical quantity is called a parameter. Example of a parameter is mean, standard deviation are the example of parameter. Next is statistical inference. It is a process by which draw conclusion about parameter or distribution of population based on samples drawn from population. That is, we collect some samples from a population. Based on that population, we analyze to give conclusion about a given population is called statistical inference. The two type of statistical inference. One is testing of hypothesis. Second one is estimation. So two type of statistical inference. One is testing of hypothesis and other is estimation. Statistical inference is the analyzer, the information of conclusion about the population based on samples. Testing of hypothesis. Testing of hypothesis means it is a process or procedure which a statistical hypothesis is laid down and it is accepted or rejected random sample. So we have a hypothesis, that is we have some assumption that is accepted or rejected. That testing is called testing of hypothesis. The commonly used statistical tests are set test, t-test, f-test, etc. So testing of hypothesis is an act or procedure for which statistical hypothesis is accept or reject of a random sample from population. We decided to that hypothesis is accept. We needed to decide that hypothesis is accept or reject. So such a type of process is called testing of hypothesis. Term is simple hypothesis. Simple hypothesis defined as if a hypothesis is concerning the population completely, such as functional form and parameter, is called a simple hypothesis. That is, simple hypothesis reflects a relation between two variables. For example, our statement is lower level of hemoglobin. So this statement is an independent variable. Lower level of hemoglobin is an independent variable, but it depends risk of infection, that is dependent. So these two variables relation we can say. Such type of hypothesis is called simple hypothesis. But other type of hypothesis are called complex hypothesis. That means the statement reflects the relation between more than two variables, is called complex hypothesis. So more than two variables relationship. So some hypothesis reflects more than two variables. Such a relation is called complex hypothesis. For example, among some of the patients who are old and dwelling in rural area than those who are younger and dwelling in urban area. So this have that patient depends on the area, what is an area, and her generation, old or general, younger. So that's a more than two variable depends. So such type of hypothesis is called complex hypothesis. One more example I will say for complex hypothesis. The daily weight loss is greater for adult who follows a reduced calorie diet and exercise, food, etc. So our statement is daily weight loss is greater for adult. That is the statement. That statement depends on their calorie diet, exercise, daily exercise, food type of foods, etc. So our statement weight loss of adult, that hypothesis depends on more than two variables. Such is called complex hypothesis. Next term is parametric and non-parametric hypothesis. A hypothesis which specifies only the parameter of the probability density function is called parametric hypothesis. Otherwise is called non-parametric hypothesis. That means a hypothesis specifies its parameter. That is called parametric hypothesis. For example, our hypothesis is mean of the population is 25. So our hypothesis specifies the parameter. Mean is the parameter. That parameter specifies. Therefore, such type of hypothesis is called the parametric hypothesis. Null hypothesis and alternative hypothesis. These are the two statistical words for testing of hypothesis. Null hypothesis defined as it is a statistical hypothesis which is stated for the purpose of acceptance. That means the null hypothesis is a original hypothesis. We have one testing content, testing observations. We have some observations. That observation satisfies. We need to check that observations satisfied some property or some possibility is acceptance or rejectance. That we need to check. That acceptance, possibility of acceptance statement is called null hypothesis. And we have another hypothesis. That hypothesis is called alternative hypothesis. Null hypothesis denoted by H naught. And alternative hypothesis is denoted by H1. We have, I will say one example. We have sugar patients list in one hospital. We need to check hyperactivity is related or not in sugar patients. So we take our hypothesis is hyperactivity is unrelated to sugar patients. I take one statement, hyperactivity is unrelated to sugar patients. So, test statistic. It is the important word in testing of hypothesis. It is a test statistic is a some formula, like a formula. The definition of test statistic is the decision accept or reject a null hypothesis is made on basis of statistic computed from the sample. We have a samples. We need to check our null hypothesis. So we need to check null hypothesis means we have to calculate some data. So that null hypothesis accept or reject is decided to based on the test statistic. So So we have a test statistic on each of the test. So we use that test statistic for the null hypothesis, accept or reject decision. The commonly used test statistics are T, F, chi, T, Z, etc. Next term is sampling distribution. Sampling distribution is obtained for a sample statistic. Is called a sampling distribution. Sampling distribution is a distribution that obtained from sample statistic. Next term is standard error. The standard deviation of sampling distribution is called the standard error. We have standard population standard deviation, sigma, and total size of sample, n. Then standard error. We need to calculate standard error. Standard error equal to sigma by root n. Standard deviation of sampling distribution is called standard error. Standard error calculated for the formula sigma by root n. Next term is level of significance. Level of significance is the probability with which we may reject a null hypothesis when it is true. That probability is called the level of significance. That is, we reject a null hypothesis when it is true. That probability of rejecting null hypothesis when null hypothesis is true, that value is level of significance. Null hypothesis is accepted or rejected based on the level of significance. Usually we denoted by level of significance is alpha. Usually we take a level of significance is 5%. That can be written as 0.05 level of significance. Alpha is 0.05. That means the statisticians is rejecting null hypothesis 5 times under the 100 every 100 times when null hypothesis is true. Once more I will explain. If we take alpha equal to 0.05, that means level of significance is 0.05, means statisticians rejecting null hypothesis 5 times under the 100 times when null hypothesis is true. We have 100 times. The observations are 100 times. So we take the null hypothesis is 100 times. That is rejected or accepted. Sometimes accepted, sometimes rejected. So 5 times rejected when null hypothesis is true under 100. That is the meaning of 5% level of significance. Now we get level of significance. Level of significance is the probability of rejecting H naught when H naught is true. In any testing of hypothesis, the decision is accepted or rejected. We have four possibilities. We have a null hypothesis. Null hypothesis can be accepted, otherwise rejected. Null hypothesis may be accepted or rejected. Null hypothesis may be true or false. Based on these criteria, we can divide it four possibilities. H0 accept, null hypothesis accept when H0 is true. Null hypothesis reject when null hypothesis is false. H0 reject when null hypothesis is true. H0 accept when null hypothesis is false. We have four possibilities. But H0, when H0 is true, we can accept H0. That is correct. H0 is false, we can reject H0. That is also correct. So these two have no errors. First two are correct. But H0 is true. When H0 is true, H0 reject. So if H0 is true, then H0 reject. That is a false statement. So there have an error. We conclude this means we have an error. Similarly, when H0 is false, H0 accept. H0 is false. Then H0 accept. This also error. We take H0 false, then we accept H0 means there is an error. So these two are correct statements and we have these two are errors. So we got an error. So these errors are called type 1 error and type 2 error. Type 1 error is when H0 is true, H0 rejecting. Type 2 error is H0 is false, then accepting H0. One example. Our null hypothesis is population mean is 125. We have a samples. We used test statistic. Then we got an idea what is a population mean. We got population mean is after the testing we got population mean is 125. But we decided to reject null hypothesis. We got population mean is 125. H0 is true. We got H0 is true. But we decided H0 rejected. That such type of error is type 1 error. Type 2 error means we have an H0 population mean 125. Used by test statistic, we get population is not 125. Population mean is not 125. But we decided to accept H0. Such error is called type 2 error. Type 1 error is we have a null hypothesis is 120. Population mean is 125. We used by test statistic. We got population mean is 125. But we decided H0 reject. Such type of error is type 1 error. We have a null hypothesis. Population mean is 125. Used by test statistic, we get population mean is not 125. But we decided this accepted. So statement is false, but we decided to accept null hypothesis. Such type of error is called type 2 error. Degree of freedom. One of the important terms, statistical term, is degree of freedom. Degree of freedom is number of independent observations. Degree of freedom is number of independent observation which obtained by subtracting the number of constraint from the total number of observation. We have total number of observation, total number of observation minus number of constraints. That is equal to number of independent observations. Number of independent observation is called degree of freedom. In the case of set distribution, degree of freedom is infinity. And in the case of T distribution, degree of freedom is n-1, where n is number of observations in the sample. The rejection region is called the critical region. The range of variation we can divide into two regions. One is accepted region and other is rejected region. The rejected region is called the critical region. Level of significance of rejected region is alpha, and level of significance of accepted region is 1 minus alpha. Value of test statistic which separate the reject region from the accepted region is called the critical value. Sample size exceed 30 when we call large samples. The sample size is less than 30, then we call it as small samples. Procedure of set test. We have an observation. So we set null hypothesis. We denoted by H naught. Null hypothesis denoted by H naught. Next step is we decided to testing. Which test? Set test or T test? If sample is large, then use the set test. If samples are small and the standard deviation is unknown, then we can use T test. If sample is small and the standard deviation known, we can use set statistic. So based population mean known or not and sample size, we get which test, set or T test. Then the third step is test statistic. Test statistic is x bar minus mu naught by standard error. X bar is sample mean, mu naught is population mean, and standard error calculated by following formula. Following one of the formula. Sample space is large or small. Population standard deviation known means we can use sigma by root n. Population mean is given. We can use sigma by root n. We didn't think about sample size. But population standard deviation is not known. We think about sample size. Population mean is not known and sample is large. We will use S by root n. population standard deviation is not known and sample is small, we used S by root n minus 1, where S is sample standard deviation. So these three, one of the formula of these three, we get a standard error. Used by this formula, x bar minus mu naught by standard error, we get a calculated value of corresponding statistic, Z or T statistic. First we decided Z or T statistic. Then this used by this formula, we get a calculated value. Next step is we get a Z test or T test. So if we decided Z test, then degree of freedom is infinity. If we decided the test is T test, then degree of freedom is n minus 1. In the corresponding level of significance and degree of freedom, we get a tabled value. So first we get a calculated value. Here we get a tabled value in statistical table using by level of significance and degree of freedom. Then we can conclude if calculated value is less than tabled value, we accept null hypothesis. Otherwise, we reject null hypothesis.